Find domain of each function and write the domain in interval notation. So in part A, we got y equals 2 plus absolute value of 3 minus x, okay? And in fact, we don't have a fraction here, no square root. So absolute value of anything is defined in fact, and plus 2 is also defined. So there are no x values for which this is undefined. That means the domain is set of all real numbers. Okay, so the domain is all real numbers that we write in terms of interval as negative infinity through positive infinity. Part B. So we have y equals cube root of x plus 5. In fact, cube root is defined for positives as well as negatives, so no problem on the top. This is good. On the bottom, since this is a fraction, we cannot have 0 on the bottom because something divided by 0 is undefined. And look at here, this is already factored, 3x quantity x minus 2. So 3x quantity x minus 2. Let's see where this bottom is 0. So it's already factored, so either 3x 0 or x minus 2 0. From this factor x minus 2 0, we get x equals 2. From this factor 3x 0, we get x equals 0. That means at 0 and 2, the bottom is 0. But for all other values, we are good. So the domain looks like the following. So here is number line, negative infinity through positive infinity. We need to exclude these two numbers, 0 and 2. Okay, so we have holes here, 0 and 2. So then how do we write the domain? Negative infinity through 0, 0 to 2, and 2 to infinity. So for this, domain is negative infinity through 0, 0 to 2, and 2 to infinity. Okay, 0 and 2 are not included. Let's go to part C now. So 3x minus 9 on the top, no problem. On the bottom we got square root. So square root of something. So this inside, in this case 9 minus 3x. Okay, we know that square root is defined for non-negative numbers. So as long as this thing is bigger than or equal to 0, we are good. Because square root of 0 is 0, and square root of positive numbers are also good. But we cannot have 0 on the bottom, so we can have only positive. So 9 minus 3x bigger than or equal to 0, because this square root comes on the bottom, so we have only this part. Okay, 9 minus 3x positive. So this argument should be positive. Now we can find the x value from here. I would just move negative 3x, means add 3x to the both sides. And 9 bigger than 3x. Now divide both sides by 3. So 3 goes 3, 3 goes 3 times. 3 bigger than x, that is same as x less than 3. X less than 3. Okay, so the domain in this case is all real numbers less than 3, x less than 3. So let's write over here. So domain is all real numbers less than 3. So in the number line we can show in this way, all real numbers less than 3. So 3 and smaller. So negative infinity through 3. Okay. Part D. So we got a square root on the top. So the argument inside the radical sign, 5x minus 10. Okay, that 5x minus 10 should be bigger than or equal to 0. In this question we can take equal to as well, because this is on the top. We can have 0 on the top. So in the previous question we just wrote strictly bigger than 0 because we cannot have 0 on the bottom. So from this, let's solve for x. Add 10 both sides. Divide by 5. So that's the case. So just from the top we see that the domain is all real numbers bigger than or equal to 2. So in this number line, bigger than or equal to 2, so bracket and 2. But there might be some restrictions from the bottom. Okay, let's see that. And we cannot have 0 on the bottom, so we got x squared minus 9 on the bottom. Let's find the x values that make the bottom 0. So x squared minus 9, 0. Now we can factor, or we can move 9 to the other side. X squared, add 9, take a square root both sides. So x is 3 plus minus 3. And we cannot have this because bottom cannot be 0. So this is in fact this. So x cannot be positive 3 and negative 3 from the bottom. So this is x bigger than or equal to 2, by the way, and cannot be negative 3, which is outside. So already excluded. Negative 3 is already excluded, but we need to exclude 3 as well. Okay, from the top we needed x bigger than or equal to 2. From the bottom we need x not equal to positive 3 and negative 3. Negative 3 is somewhere here, which is already excluded. So we have this, then this is the domain. So let's write that in terms of interval notation. So starting 2 to 3, because we need to exclude 3, and union 3 to infinity, final.